So I woke up this morning and was going to.
Hello, everybody. This is Plan B. This is Geology 351, and I'm looking directly into my laptop computer. And I doubt this will be super effective, but at least you'll be part of the classroom here a little bit. And we'll just try to do this. The only problem is I'm going to be a long way away from you. And maybe got an idea.
And I would say glued to that screen, right? So I'm talking to my coworkers about it. And they're like, it's giving me fragile masculinity. I'm like, dude, this is the coolest.
Thank you for joining us. We're going to start in 5 minutes for class number 2 of Geology 351. Thank you. I'm going to move you to the front table with this Ethernet cable. And you'll get the front row seat. Julie, can you make space for me on the corner? I'm going to set this laptop right in front of you. I think so. I'll even get rid of that. Thank you. Thank you. Okay, everybody, man, this is super improv time. Woo. How many we got? Can you go back to that other stream and send people here possibly? I don't even know what I ended up calling this thing. Oh, I'm on the old stream. I got to find this new stream before we start. There's a lot of great energy in the room. Great energy. It just sucks that I have to deal with this. Come on. How many are in the live chat? Come on. What the
Oh, wait a minute. Hey, that's a nice.
Welcome, everybody. We're going to start in 2 minutes. Many of you have figured out that our new routine is finding which laptop or which handouts you do not have. If you missed our very first meeting, there's a couple extra things for you there. But the general rule is grab what you do not recognize and add it to your collection. I can't even get us on the line on my iPads. There's 250 with us. Why can't I get us on this? Screw it. All right. Woo-hoo. Same.
You got this, Nick. There you go.
Yeah, I have this one, and then I have a white one that I wore on the
It's high noon, everybody. Thank you, thank you, thank you. Scene is here. There we go. Let's go for this. I've got plenty in store for you. Scene, there's an open chair right here for you. Please come here. Have a seat. Thank you. All right, good. So I want to, as always, start with some interesting content. I always try to kind of lower the boom with a couple of major surprises with our lecture content. And then halfway through, I will talk about oak trees and yellow pens. Don't understand. Then I'm going to talk about stratigraphic column, which you have. You have a handout. And we'll talk a little bit about Drumheller channels, where many of us are going today. Sabrina, the grad student, is here working on her sandwich, and she'll take good care of you. She and Ryan will be doing the driving today. And as soon as we are done here at 12:50, I'm going to suggest 20 minutes or so to use the restroom and just kind of figure out what's going on. Sabrina and Ryan will be posted out at the vans. They're out there just outside of the Health Sciences building, you know, our usual geology parking spot. The two white vans, they're the only two white vans out there. I'm guessing you guys should leave about 1:15. And you'll be arriving about 2:30 at the field site, and I'll be catching up with you guys and arriving about the same time in my little white car. Hope to see many of you out there, but that's not what we're doing right now. We're doing content. So I enjoyed our first meeting. We were talking primarily about the Yakima basalts, but I was also introducing the Ellensburg Formation. And I want to introduce some breaking concepts first, but I think I need improv time right off the bat. I think I need to reestablish our crossroads sketch. In fact, somebody can draw it for me verbally. How do I do a crossroads sketch from the last time? What was I doing here? Somebody use some words, please. Arrows going from both sides. We had arrows, and what were we trying to indicate? Whoa. What were we trying to indicate with the arrows? Somebody else.
From the west is coming from.
Interfingering, dirty, right. And what was that, Jess? Or indigo?
The west arrows are coming from the Cascades and the east arrows are coming from like rivers and stuff.
So we were talking about source. We were saying nothing was made here. Everything was brought in. And we said that stuff is coming in from the west, from the Cascades. And those are the what layers? What formation seen? Ellensburg Formation. Ding, ding, ding. Good job. Ellensburg Formation, sourced in the Cascades, moving west to east, flowing into our area. And so some, not all, but some of these layers are Ellensburg Formation. Sedimentary units. This is review, just locking you in. And then there was stuff coming from the east and flowing to the west. Somebody else? What's that? That's the Yakima basalt. Thank you. And we said the fissures for the Yakima lavas are almost over by Idaho. Stumbled on that for some reason. That's the crossroads. Slow, getting myself down. This all got screwed up somehow by me. So now I'm like, this is plan C, like live streaming through my laptop. So I think I'm finally settling. So there's a guy named Andrew Sadowski. Do you know the name?
Yes.
What do you know about him? Andrew Sadowski.
He's a mapper.
USGS.
He is not USGS. Well, who does he work for?
Washington.
He works for the Washington Geological Survey. the Washington Geological Survey. Your close personal friend, Jordan Carey, this quarter is working full-time for the Washington Geological Survey. Just this quarter, hopefully. But Andrew is definitely a full-time, multi-year field mapper for the Washington Geological Survey. And he has an office at the end of the hall, first floor. If you walk in that building regularly, sometimes you'll see kind of a guy who's got his door propped open a little bit. He's got a little sign that says like in a meeting or knock, come on in or whatever. You know, that's the guy, Andrew Sadowski. How many people have literally spoken to Andrew Sadowski so far? Just a few of you. Okay. So he has an office here, and yet he works for this outfit in Olympia, Washington, the Washington Geological Survey. Andrew, are you watching in your office right now, live? Can you type in and say hi? Andrew on Tuesday watched the live stream from his office, and then when we were done, and Nick from South Africa was doing a beautiful job talking to the home viewers, Andrew slipped in, handed me a piece of paper, and then came to my office after our class and said, I kind of wonder if the Ellensburg Formation is totally sourced in the Cascades. Some of it is. What parts of the Ellensburg Formation for sure came from the Cascade? Those that know the Ellensburg Formation. What kind of deposits are we talking about?
Lahars and stuff.
Lahars. So there are some volcanic mud flows, some lahars. If you took 101 here, you went out to the Thorpe Lahars if it wasn't snowing too badly. And that's volcanic mud flow from the Cascade. It truly is one of these things here. And there's river deposits coming from west to east, and there's ash falling out of the sky coming from the Cascades. But this frickin' guy, Andrew Sadowski, and I don't begrudge him, I'm happy. We might even shift the focus of our class. Because Andrew kind of says within 3 minutes of sitting in my office, I'll basically paraphrase. Nick, you do remember there's a bunch of muscovite in the Ellensburg Formation. Oh, has anybody seen muscovite before? Chris, what's it look like? You're a minerals guy.
It's flat and plate-like, pulls apart, flakes.
It's those fragile. Here, look at this. I am prepared. Here's a huge wad of muscovite. This is sexy. A huge wad of, this is not a rock, this is a mineral called muscovite. You know the close cousin biotite probably better. Biotite is the black mica.
Is that,
But yeah.
that sheet silicates? Is that what-
Yeah, could be. You're more fresh out of mineralogy than I am. Yes, they are. All right, so yeah,
Yes.
confirmation, thumbs up. So apparently, and if you guys are excited about this, we might go further. But apparently, if there's not that much muscovite in the Cascades, the rocks that are up there are granites, they're volcanic rocks, of course, it's the Cascades. But I don't know if it's an urban legend or if it's truly a known thing in Washington State geology. You'd think I would know, but I guess I don't. Apparently, if you find a crazy amount of muscovite in your sedimentary or deposit, the source is to the north. The source is in the Okanagan Highlands. The source is north of Grand Coulee Dam. The source is northeastern Washington. Why not? I feel like really leaning into this because I don't know how far we want to go. Now, James here is about to graduate. James has already got an internship set up with the Cascade Volcano Observatory. James is going to work on some very young vents in the Cascades. Part of the reason you're here is you want to talk about modern Cascades. We might even build part of the class around your favorite cone or two or vent or two. Sexy. But we might, as a group, James, say, you're sexy, and your volcanic vents are sexy, but we're going a different direction.
Oh, yeah. Here for it.
Because if this is Ellensburg, and it is, And this is the Ellensburg Formation in central Washington. And it's got a shitload of muscovite in it. MUSC, muscovite. Little delicate muscovite flakes. I'm not talking about huge books of this stuff. But I'm talking about granites. I'm talking about other very, very old bedrock units in Washington. And we can follow this if you want, but apparently this is the homeland. This is the homeland for old igneous and metamorphic rocks that are loaded in muscovite. And I hope you can see what I'm saying. If we have a bunch of sedimentary deposits in our neighborhood that were brought in by rivers, the question is, are we talking about major river stories? You tell me when. What time frame are we talking about? From, well, careful now. Remember our chalkboards from Tuesday. We landed with some red chalk on the time window that we definitely want to fall in love with this term. What is it? From when to when? 16 to 3. So if we love this story, and our muscovite flakes are in the Ellensburg Formation, and they are between 16 million years ago and 3 million years ago, then we can start wondering and looking for science papers that talk about rivers. You're like, which rivers? It's like, I don't know, the Columbia? I don't know. Maybe rivers that don't exist anymore, or rivers that have been totally rerouted. Saying, get off the phone. This north to south scene apparently is real. And if that doesn't do it for you, I'll just throw in another one. We talked briefly about the Ginkgo lava flow last time. Can you find it on your sexy new handout? Speaking of sex, this is sexy galore. Saying this is yours when I'm done showing the home viewers. So you can find the Ginkgo flow. It is the lava flow directly above that vantage sandstone that most everybody didn't know anything about last time. What's famously been found in the base of the Ginkgo lava flow? Petrified logs, not just a couple sticks, like big ass logs in the pillow zone at the base of the Ginkgo lava flow, which is basically right there at the boundary between the vantage and the Ginkgo flow that's right above it. There is an ungodly variety of petrified logs in the base of the Ginkgo. I'm not going to list them all, but it's basically every kind of tree you've ever heard of, including oak, in the base of this Ginkgo flow. Petrified logs. Now, nobody in geology is saying that there were forests of trees in central Washington. What's the date? Roughly for the van, 16.1 or whatever, 15.9. Nobody's saying there was a forest of sweet gum and redwood and ginkgo trees and oak trees and cypress trees. And I mean, that's impossible to have all these softwoods and hardwoods all growing together. So they were all brought in from somewhere. Can anybody connect what I'm doing right now to what I was just doing with the muscovite?
Big river.
Big river. Maybe these frickin' trees. Those are trees, okay?
They look like it.
They look like trees.
Yeah, they do.
Maybe we're talking about a collection of petrified logs, trees that were once living and growing to the north in muscovite land. And I don't know, like how many sedimentary layers within the Ellensburg are full of muscovites. How many different Ellensburg Formation layers have petrified logs? I mean, we could get carried away and never get to James's modern Cascade stuff. Reaction, questions. I saw some hands or some tentative hands. Joe.
Yeah, in 377 last quarter, we learned that the trees that were found, there was a bunch of different species, right? But some of them grew at higher elevations.
Right.
Some of them were lower.
Right.
So Lisa was the teacher for that. And
Yeah.
she came to the conclusion that rivers flowing from the Cascades would knock the trees down and bring them down here.
I love it. So Joe's reporting on his prior class last quarter, Geology 377, taught by Professor Lisa Ely. She's very knowledgeable. She based much of her class on some scientific papers that talk about the Cascades as the source. Well, I may look conventional, but I like to teach unconventional stuff. And so we're going to wonder if those trees really did come from the Cascades. It's a tentative thought, but again, the first message from, I got one more, so that's one stink bomb that we're throwing in the class, muscovite. Didn't see that coming. I got something in my other pocket before we hear from Steve.
Oh,
No, please, I insist.
what was it, Joe?
This is Joe.
Yeah.
Joe, scene.
Was it, hi, subalpine, alpine?
It's tons of different trees. Yeah, I don't remember the actual.
Okay.
I don't know the actual species. All I know that there was a bunch that grew at the higher elevations.
Yeah.
Or elevations that grew from.
Yeah, good. Okay, so there's volcanic mud flows that are in the Vantage. Did the mud flows carry the logs? Did the mud flows have the muscovite or something else? So we'll just linger that out there and see if you're interested. But what was the thing in my other pocket? So I went to grad school, everybody. Thank you. I went to grad school.
Well done.
Thanks. Nailed it. And I don't think in all those grad classes in the 1980s, we ever mentioned the word zircon. Ever. Like I'd never even heard of a zircon when people started talking about it in the 1990s. And I remember saying, I don't think I was sleeping in my classes in the 1980s. What's with this zircon thing? They're like, this is this newest thing, man. Get with it. Zircons are super durable minerals that can record all sorts of data. And people are now, they don't care about biotite. They don't like potassium argon dating. They don't care about that. They want to look for these zircons. And some people in this room are out on the trail of zircons up on the 3rd floor. Mount Baker, Goat Rocks, and everything else. It's still sexy 30 years later. This is the drinking word today, sex, apparently. Scene doesn't approve.
No idea.
What is a detrital zircon? I've just defined in my own weird way what a zircon mineral is, and it's a mineral found in certain kinds of igneous and metamorphic rocks to help us get very precise dates. But what is detrital zircons? Anybody heard about that before? Or can you guess? Ryan?
Is it zircons that are like in sediments?
They are.
And they come from like ripping out of the rocks.
We're going to erode the bedrock. We're going to free up the zircons that were held in prison in that bedrock, and we're going to move them. And if you have enough detrital zircons, so detrital means we're moving them. You can I think of it just like river carried zircons. I'm leading to something pretty big out of my left pocket here in just a second. And I don't want to stop for Nick or anybody else until I get to it. The Muscovites tell a source story about the northern part of Washington, coming from the Ellensburg Formation. So Andrew Sadowski, if you're losing the thread, Andrew Sadowski, in a very polite way, says, I'm just not sure everything's coming from the Cascades, buddy, for the Ellensburg, including his mapping. I have his beautiful 5 maps and cross sections and detail that he's published. These are the 5 years prior to this year that he's been mapping in our neighborhood. We're going to use these maps a lot. We might even have Andrew in a few times to work with us. But Andrew also said, don't forget about the detrital zircons in the Ellensburg. I need another color. So what's detrital zircon? It's not muscovite, it's zircon. It's a different little, think of a sandstone. So some of the sand is not sand, it's little flakes of muscovite. And some of the sand is truly sand, but it's not quartz, it's this little mineral called zircon. And you can collect all this detrital zircon, red, zircon. And you can carefully look at the minerals the mineralogy of no, wrong. They're all zircons. You can determine the source of the zircons by studying the ages of the zircons. And there's enough data now to say, holy shit, I've got a sandstone that's 10 million years old in central Washington from the Ellensburg Formation, but 35 of these zircons are like 1.1 billion years old. And then you start the hunt for the source of the 1.1 billion year old zircon. Are you following me? Well, I'll just cut to it. A colleague of Andrew, Lydia Steisch, who works for the USGS. I'm coming to you, Nick, in just a second, I promise. Not yet, though. Lydia's been publishing in the last 5 to 10 years. Okay, I'm getting chills about before I do this. She's got a pretty convincing case that a bunch of the zircons, detrital zircons, in central Washington in the Ellensburg Formation came from here. There's bedrock in southern Idaho that was eroded at some point, and then how the hell are you going to get these very old zircons to central Washington? You got this through Hell's Canyon, you got this before the Blue Mountains were there. What I'm trying to say is, if we get carried away and we all decide this is interesting, we can be going through the Ellensburg Formation, fine. But we can be leaning into non-cascade sources, and therefore we're going to be doing a bunch of river maps, essentially. Some of it we're trying to dream up ourselves that nobody's published. Some of it we're going to find some papers that do have some maps that have rivers that are bringing these exotic things to us. So I'm finishing up, and then we open it up to discussion. I can tell that you want to talk now about this, and I'm grateful for that. The muscovite flakes are a non-cascade source. It appears it's a northern Washington source. The detrital zircons that have also been found in some of these Ellensburg Formation sedimentary beds are coming from as far away as southern Idaho. Do we care? Do we want to just go nuts with that and have 3 different sources of stuff coming into our Ellensburg Basin and basically lean into river stories? Nick, thank you for your patience.
So you mentioned some of the zircons were 1.1 billion years old.
I made it up, but yeah.
Oh, okay.
I mean, no, some of it is truly Precambrian.
Okay. 'Cause I was just going to ask, are most of them that age, or is it just kind of a mixing pot?
It's a mixing pot hodgepodge, but the most dramatic of the zircon data sets are the super old ones. That, you know, we're talking about detrital zircons that are older than the state, and yet they're here pretty close to the surface in these youngish sedimentary beds. So I made up 1.1, but there is some bedrock in southern Idaho that matches that. Jess is looking at her map. You all have it. That's a gift from the Washington Geological Survey as well. You all have your own kind of generalized Washington geologic map. I don't know how much we'll use it each day, but it's kind of a fun. Were you looking for something in particular?
Just looking at how rivers are flowing.
Yeah, how the rivers are flowing today. I mean, we could be going there. We really could, if you feel like it. Indigo.
Where is the path of the Snake River? Like, it comes out of somewhere in the Rockies. Well, I know where it is in Washington, but in Idaho, I don't really remember that.
Let's do this a touch, and then we will decide at some point as a group if we're really doing this for real. The Snake today starts in Yellowstone Park. It goes through Jackson Hole, Grand Teton, goes by my in-laws' house in Pocatello, goes across. Then it goes through the Hell's Canyon and makes the state line between Oregon and Idaho. And then it kind of loops up in here and gets to the Tri-Cities. Ryan.
So,
and then Gavin.
These old zircons they're in the uppermost layers, but are they also like in infrared or interfeeder layers with the CRP?
Good question. The detrital zircons that I'm familiar with are on top of the Yakima basalts. We could go there. There's one. So you have it. I'm going to borrow this. So on this strat column, there's all this yellow. And up until Lydia, I think it's safe to say, up until 10 years ago, everyone assumed that everything in yellow was coming from the Cascades. Everything yellow is Ellensburg Formation, if you haven't made that connection yet. There's all these local names, but it's all collectively called the Ellensburg Formation. This ties to what we did last time. But I've got CPT Roman numeral 7, CPT Roman numeral 11. That's the Cougar Point Tuff that everybody thought was coming from the Cascades. It came from a Yellowstone-like explosion in southern Idaho. And Lydia, I won't talk more about her right now. What was the question?
Are some of the
Right. Right. Are some of them old enough to be in between our lava flows? I don't know, but I suspect that is the story if we really start looking carefully at this. At some point, we're going to have to vote or something, like if we want to keep going in this direction.
Well, wasn't
Gavin.
the goal for the quarter was to listen to the Ellensburg Formation and to dive
One of my goals was to listen to the Ellensburg Formation, and even a more important goal was to listen to the people in the room and try to get a sense of what excites them. Because I think maybe as we go younger and younger in the Ellensburg Formation, we get more and more cascades. I don't know if that's true. That'd be fun to find some sort of trend. Like if we have three distinct sources, I need more colors. If we have three distinct sources, a north source, a west source, and a south source, is that true up until 7 million years ago, and then these other sources go away, and then it does become a cascade source? That'd be a fun thing to find. Zane.
So, could there have been, is it possible that there was rocks that would have been that age and produced those zircons on top of what is now the Cascades or in northern Washington that would have eroded away?
Creative thought by Zane.
Right there currently?
Yeah, Zane's wondering, is it possible to have these old bedrock units in northern Washington, but then were eroded away so that there's no trace of them, and yet we have the trace down here? It's very creative. Typically no, because those super old bedrock units have been down below, and it's just a feat to get them to the surface to start eroding them. I can't think of something that was beneath that necessarily. A couple more, and then we'll go to the next part of the program. I'm loving the vibe from many of you. Gavin, finally getting to you.
So I'm relatively new to the whole mineralogy subject.
Me too.
And this could be a question to the class of people who have taken mineralogy. How do we use zircons to age rocks? Like, what are we looking for?
I'm going to put that one on hold. I think that's going to take us in a whole nother direction. The simple answer, I like that you're asking everybody, but I want to keep us going to one particular goal here today. The zircons can record an incredible amount of age data and chemistry data just by their physical properties. And we just didn't know the benefit of digging into those zircons. Sabrina and others are literally working with zircons with tweezers and running them all through instruments on the third floor. And other minerals are so simple and not durable and not that old that so they're little time capsules. They're little beautiful little treasure chests of information that we have learned how to really capture in the last generation. Again, nobody was doing it when I was your age. Two more, we're moving on. James.
I would be interested to see how the paleocurrent data would show, especially if we have like potentially two different sources, like if we get closer to the Cascades of the paleocurrent more from the west or from the south.
Thank you, James. So James is wondering about, can we look at the paleocurrent data? Again, I'm trying to talk to everybody in the room, some who are right out of 101. You can look at a sedimentary layer, and if there's enough energy with the rivers, you can study the Nike swooshes, the angle of the Nike swooshes to figure out the speed of the water, the direction that the water was traveling. James is thinking out loud, can we use some cross-bed data sets and muscovites and detrital zircons and have them work together to make a compelling story of an old river system? That's been done, and we can get into those papers. And maybe we will ultimately just saying, we really, I don't know, this is me now. I almost want all the Ellensburg to be cascades just because it's nice and simple. And then if we just keep running, God damn, another unit that's got crossbeds going the wrong way, James? This is bullshit. And then we go, okay, well, I guess she's right. I guess it's coming from someplace else. Chris.
In regards to what you were talking about, all that. For mineralogy, for our project, my project in particular, I did the Hauser Lake Gneiss.
Okay.
From the research from that, it explained that like where Priest River complex is,
Right.
it runs all the way down to there.
That's a part of this.
And the samples they pulled from that, the core samples, had zircon in it and muscovite.
Good.
So
good.
I was
Okay.
just thinking that perhaps some of the reason we have some of that is that had to be the original coastline at some point before Cascades got uplifting. So it just doesn't seem shocking, I guess.
Doesn't seem shocking to you. So yeah, Chris is reporting on his experience with the Hauser Lake Gneiss and the Priest River. All these metamorphic core complexes are a similar story. It's a regional story. We can go there. Back to the outline. Let's take a pause. 12:30. Good. Do we still have people here? 555. Stupid old little laptop thing. I hope you can hear me okay. Okay. I'm loving this. I'm loving this. Thank you. Oak trees and yellow pens. All right. So I mentioned that there's a website, nickzentner.com. I don't think I need to write it again. I wrote it last time for you. My name, nickzentner.com. And in the upper right-hand corner, there's 351. That's us. And I am starting to post science papers under that number, 351. And you remember now, every weekend, I'm sending you an email. Not everybody's been good about replying. You need to reply. I'm trying to use real world grown-up skills in this class. Like I didn't give you a list of things to bring this afternoon. I didn't tell you which socks to wear. You're fucking grown up, okay? So part of this is I'm sending you one email every week and you're replying to my email saying, got it, ready. And from this point on, every weekend email, I'm going to have some science papers. And I want to right now tell you what I'm expecting you to do with these science papers and how to read a science paper. Some have done this already. Some are brand new to even what the concept of science paper is. But I want to do it right now, once and one time only. Now, I am married. I'm happily married. But if I was single, what's the app I could use to find a companion? Tinder? What else? Does Bumble still exist?
Yeah.
Okay. What other apps are people using these days? Facebook? See, you got to get off of Facebook. That is not working. No. Okay. All right.
StaySingle.com.
StaySingle.com? Oh, I'm going to have to try that one out. Okay. So what I'm getting to is if I had my new Tinder profile, maybe I should do this. Maybe we should use the overhead projector. Make a Tinder profile for myself. I would describe my most intense pleasure as this. I take a lawn chair, I set it under our oak tree in the backyard. I print out a science paper that I haven't read, and I use I got 25 of these little yellow pens, and I found them on Amazon. They've got just the right width, just the right heft. They're not too fat. I went to all the reviews, and a bunch of people who love writing the Bible love these pens. So I call these my Bible pens. And I systematically, and I mean it, that's my thing. Oak tree, science paper, underlining certain things and enjoying learning new things. I just feel productive. I would do it even if I wasn't a teacher. But I want to describe to you my process. I mean, the lawn chair is optional, the Bible pen is optional, printing is optional, the oak tree is optional, Tinder's optional. Here's what I do. There's an abstract. It's the first paragraph or two. It's the main messages of the paper because all of these scientists write with the same format. I read the abstract 3 times before I do anything else. And I use my Bible pen to underline words that I don't understand. And I'm 62. I should put this in my Tinder profile as well. I still don't understand half the words I read. It's true. But it doesn't bum me out. And no, I don't, Google right away and everything else. I figure that I'll eventually figure out what some of those words mean later on. But I read that abstract 3 times. And the abstract is the heart of the matter. And I think if I read 3 times, I can get the first 2 main messages from this geologist without ever reading anything else in the paper. That's my goal to myself. Sometimes if I really want to do well with the paper, I have a tablet of blank pieces of paper, and I try to write out 2 sentences about what I think this author is trying to gift to the world, just from reading the abstract 3 times. Then I start looking at the pretty pictures. I don't read all the body of the text. I just go right to the diagrams, the pretty pictures. This is one of them that I have waiting for you. And I do the same sort of thing. What can I follow? What do I think I understand from my past experience on the planet? Or I'm just studying, like, why did they use these color choices? I read the little explanation down below the map. Here's 3 or 4 photos from the field. Here's a chart. Takes me a while to figure that out. So I spend probably a good 10, 15 minutes just trying to understand these diagrams and these maps and these photos. And again, the captions, I read the captions carefully, and I use the yellow pen on the captions as well. And then I read the conclusions. There's usually some sort of summary at the end. And quite often it's the same stuff that was in the abstract, but occasionally it's written a little differently. I'm like, oh, that's what they meant in that abstract. Now I think I get what they were driving at. And so maybe I add 2 more sentences to my little blank spiral notebook. And that's it. I rarely read the rest of the words. If I really am into it, or if I think somehow I'm going to be discussing it in a classroom setting as a student, then maybe I do read a little bit. But a lot of the text is background. A lot of the text is how they got their data, and they're talking to the 3 other geologists who have the same specialization. That's not me. They're not really writing it for me. And the point is, I'm not sitting down at bedtime, cuddling up with this thing and reading it from front to page like it's some sort of romance novel. It's not. Before I open it up to you guys, anytime that I mention a science paper at nickzentner.com, 351, and there are 3 of them right now. This is Jennifer Kasbaum with the most precise dates from Princeton on the Ellensburg Formation, interfingered, Nick, with the Yakima basalts. The other 2 are old man papers from the 1960s. Bingham, 1966, which I mentioned last time, and Mackin, which I mentioned, which I didn't, but I'm mentioning now, 1961, J. Hoover Mackin. And these don't even have an abstract. They're written in an older form. And I don't know how useful these will be, but I would encourage you to do the same kind of pecking around in these papers. And what I'm ultimately saying is, when we do a midterm and a final, we'll talk about that next week, but when we do a midterm and a final, and when I say, Nicolette, what was Mackin trying to get at with that 1961 paper? Nicolette's going to be ready with 2 or 3 of her sentences from her abstract. So in other words, you're going to come to class from this point on, If I mention 2 or 3 papers in the weekend email, you're going to have that looked at in the way at least that I described. And you'll be ready to talk a little bit about the paper in our discussion. Reaction, questions. Sean, you want to say something?
Oh, you mentioned the spiral notebook, so you're
Yeah.
taking notes while you're reading the paper?
I'm really, so I have, this is just my method, not required. It could just be your yellow pen or whatever system you have, and it just stays, again, you're not even printing things out perhaps. You're highlighting or something digitally. But what I like to do is write a few sentences, just a few sentences on my own that summarizes what I think I'm reading in my own words. So it's kind of taking notes, but it's certainly not going paragraph by paragraph and writing everything out. I've forgotten your name. Faye, right.
How do you choose articles?
Well, my job is to pick certain papers that I feel like we're going in that direction as a group. So you're certainly not needed. So you're not picking the papers. I'm the one picking the papers. But you're curious why I'm picking the
I'm
papers.
just curious in your free time and your research.
Yeah, the oak tree time. Yeah. Well, Andrew's probably going to take us out one of these Thursdays. And so if I know that date, then I'm going to find a couple papers tied to what Andrew's going to show us. I'm going to teach myself some stuff so that I can then teach you all, and we can have a discussion. If we love the detrital zircon thing, I'll just start emailing my friends and saying, which papers should I find? And we'll just, I hope it's obvious to you by now. I teach 351 with topics I don't know anything about. I'm not faking it. I don't know this. I don't know. And so I hope you can see that that's kind of a fun experience to be part of, that we all don't know where we're headed. And so you're part of the journey. Oh God. Anybody else on the science paper stuff? Since I'm thinking about it, Sabrina and I are going to proctor a special Wednesday in early May and a special Wednesday in early June, where you're going to be taking an old school exam. Basically essay questions, pencil, and you're going to be drawing and writing and discussing, and we're just going to take time out of our Tuesday, Thursday schedule to do that. And we'll find times that work for everybody. But that's my loose plan. I'm firming things up with Sabrina. But that's where we're headed with this. So if you're like, I'm just going to kick back, listen to this, like, I think this is going to be easy. I think he's just going to give everybody an A. I'm expecting you to master this material based out of what we're doing in this lecture. The field trips will never be on this midterm and final. Remember, the field trips are entirely optional. I want them to be fun, including what we're doing in the next hour. We'll be out there in an hour, baby. It's going to be great. Perfect weather. But I'm communicating my own way how we're going to try to evaluate you. Indigo.
Is there a reason why you don't want to use the actual final time for the final?
Yeah, let's talk about that after class. Gavin.
I was just stretching.
You're just stretching. Could you tell us about your stretching regime?
Well, yeah, I have a bad collarbone because I broke it, so my shoulders don't sit right, so I need to move it every once in a while.
Very good. Thank you, Gavin. Okay, so with our remaining 7 minutes, let's go to your sheets of paper, please. Your yellow sheets of paper. I'm setting up the field trip. Viewers, we're going to Drumheller Channels. If you really want to be out there, fine. Thank you. You got an extra?
No, I was just wondering, is this the one?
Yellow piece.
Come on, man. You know your colors? Won't they cover that in Cape Town? All right, you can look on. I'll give this back to you, I promise. All right. Of course it's not your fault. All right. So anything we do in this lecture setting is fair game for an exam, even though right now I'm talking about the field trip. Again, I'm keeping track. I have these recordings, so I'll know what we cover. I'm going to talk to everybody like you're coming. I don't care who's coming. I'm going to talk to you like we're all coming. We're going to see 3 lava flows this afternoon, and they are 3 of the many Yakima basalts. The star performer is the The star performer is the Elephant Mountain lava flow. You can find it towards the top. 11.2 million years old. That's the one that has the most beautiful columns. I should draw this. All three lava flows are going to present columns. I mean, that's one of the main reasons that this place at Drumheller Channels is so special. All the bedrock has beautiful colonnade. But it's not all the same lava flow. And there are amazing chances to see the differences between the columns. Elephant Mountain, Priest Rapids, Rosa. So if you stick with me, and you might not, you might want to go do your own thing and squirrel around. That's fine. I'm probably too slow for you. But if you stick with me, we're going to work our way to the highest plateau overlooking the whole Drumheller Channels Wildlife Refuge. And we're going to be up on top of this incredible collection of beautiful, thin, perfect basaltic columns. And they go all the way through from the top to the bottom, or the bottom to the top. People still don't really know. And you're going to ask me in an hour, why are these so thin like this? Why are they so perfect? I'll go, I don't know. Nobody knows. And then you're like, well, isn't that the Priest Rapids on the next step down? So it's like a giant staircase out there. So the top step in the staircase is the Elephant Mountain. But we'll look down to the next step in the staircase because the Missoula floods have swept this area and have taken portions of the lavas away. So maybe some people will stay down and play some pinochle on that bench. Some other people will be smoking pot on that bench. The Priest Rapids lavas have columns, but they are enormously thick. The thickest columns I think I've seen in central Washington. Don't ask me why. I don't know, man. I don't know, Nick. Why? I don't know. And if you follow the Priest Rapids lava flow, you can see it on your sketch. If you follow the Priest Rapids, 15.9, all across the state, these things are remarkably consistent in their colonnade look. It's not like they're full of columns in Grant County and then you go over to Kittitas County and they lose their columns. So there's major, major questions. I meant to point this out. That have you ever seen this over in the next room? It's been sitting on the floor. This was made by Zach, who took 351 before the pandemic, and he was an art major. He was geology minor. And I had this same community building thing with Zach, and maybe a third of the way into the class, Zach's like, I'm loving this class, thank you. I know we're studying columns. We're trying to learn about how columns form, but I'm an art major, Zentner. He said, I don't read very well and I don't speak very well. I'm going to keep trying with that, but I'm just pretty weak in those two areas. I said, okay, thank you for your honesty. He says, but I want to do something for the community. I want to use my skills for the community somehow. So on the last day of class, he walked in with this thing that he'd been working on the entire quarter. And I almost cried. It's really cool. Because he used his talent and his vision, because we kept talking about stratigraphic columns, and we kept talking about these different units. And we were talking about the Ellensburg, but not the detrital zircon and the muscovite, because I didn't have Andrew down the hall. But I'm going to keep this as just kind of a homage to Zach, the art student. I don't know where he is now. But he added to our community in his own way. And if you resist this participation thing for reasons similar to Zach, then I don't know, maybe you'd have a way to add to the community the best we can. My point is, we were focused on those columns, whatever spring term that was, and I never did get to much. I got into a bunch of physics papers and stuff, and the oak tree didn't work that time. I didn't know what I was reading. The Rosa is older yet. Is that true? I think it is. Yeah. And I don't know how to draw these. Well, sure I do. Sure I do. There's a famous rock climbing place where the climbers trying to draw French fries. Crinkle cut French fries. It's like this pinch and swell thing. I'm doing it. I need Zach here. The Rosa flow is the main columns that people climb at Frenchman Coulee. Is anybody climbing here? Have you been over Frenchman? Yeah. So the Sunshine Wall and all that stuff, that's Rosa. And there's just a couple places we might see some crinkle cut French fries in Drumhill this afternoon. But we'll definitely see the fat Priest Rapids. We'll find the beautiful, perfect little Elephant Mountain thin flows. Matthew.
Why are the Pomona on the hill not there? Were they eroded or just didn't feature?
Thank you for the question. I was hoping somebody would ask that. Matthew's like, okay, well, we're going to see those three flows. Why aren't we going to see the Pomona and the Umatilla? And the answer is simply these flows did not spread the same distance with each eruption. And so it's not really an erosion story as we understand it. It's just a simple, you can think of these Yakima basalts as pancakes, and some flapjacks made it all the way to the edge of the basaltic province, and some didn't have quite as much batter, so they didn't travel as much distance on the griddle. Okay, we are out of time. I've gotten to where I wanted to go today. 1:15, the vans leave promptly. Get out there way before 1:15 to find your spot in the two vans. You've got the Google Maps. You've got the Google Maps. Very good. I'll see you guys out there. Thank you. I love you and goodbye. See you shortly. Okay. Not ideal, but maybe, can I ask you right now, can I get some feedback on how much of that you were able to hear and understand? I got too confident. I didn't have Nat over here this morning. We have 577 live viewers. Worked fine, all fine, good enough. Okay. Thank you. Thank you. That's nice to hear. I'm glad I was able to do that. I flirted with keeping the good audio, but just a black screen. And I don't know, maybe this is a little bit better. So on Thursdays, we're not going to have anybody from the class talk to you. And I'm not going to talk much more than a couple more minutes because we head out on Thursdays. But I'll do a couple questions because I think I can get out there quicker than these guys. Any questions from today's presentation? If you were able to follow me, uppercase, please, for a few questions. Thank you for joining us today. I was yelling profanity right before we started. And these guys got very quiet. They're like, oh, shit. I wasn't swearing at you. Zane.
Question. So, when talking about the zircon origins of it,
Yeah.
It's been focused on America. Has anyone, is there anything that could be coming from Canada, something like the Canadian Rockies where the Columbia starts from?
Oh, Zane, that's a great question. You know, Zane's wondering about Canadian sources of the detrital zircons versus Washington or Idaho. You run into that all the time, man. There's hardly any cooperation between the two countries with research. And when there is, sometimes there's beautiful things that come out of the collaborations. So if we really are getting into the Muscovite story and we really like the northern sources, yeah, there could be incredible bedrock units in southern BC that are just the obvious source, but
There's nothing really between. It's been looked at
we might find there are some papers like that. Will be the fun. Like I'll try to if we decide that's the direction we want to go, I'll find some Canadian papers and see if we
I
can.
like that as like an idea. That was like one of the first things that came to mind.
Right.
It's all interconnected
Oh.
mountain range, so it makes sense.
Yes, I mean, yeah, we're so limited. It's just mentally. Yeah. Thank you. Will I record the videos in the field? I might on occasion. I like this group already. Today, AV problems notwithstanding, today was electric right off the bat. So I will want to capture these guys in the field. I've already done 2 videos in Drumheller, so I don't think I'll bother today. I'm trying to repeat the student questions occasionally, Gabriella, but I'm not going to do too much of that because most of my energy, of course, is tied to them as well. But I've always got you guys in the back of my mind, and I was thinking about maybe having a bunch of different microphones in the room, but I decided against that. Does the Idaho granite contain muscovite too? I think it does, but I don't know. Like that's a interesting. Maybe a little inventory of the bedrock units in the Pacific Northwest that are loaded in muscovite would be an interesting. That might be an interesting thing to try. I mean, I guess first things first, I need to visit some outcrops of Ellensburg Formation that have muscovite flakes in. I don't think I've even really seen that. There's a place in BC called Mica Creek. Possible source. Well, there we go. I respectfully ask that people do not join us in the field. I mean, if you really happen to be at the spot we're going, we can shake a few hands. But otherwise, I think most of you have a good sense that I'm wanting to work with the students and not wanting to work with a bunch of you. No offense. What about the zircon frequency count in the sediment deposits as a rough indicator of distance from the source? Thank you, Tyler. We're not going to have to make up these rules. Like this work has been done. I guess it's not. I kind of said it was a rumor. It's not a rumor. Like people have been working with detrital zircons for at least a generation now. So statistical approaches and plenty of rules of thumb, I think, are a thing. Does the thickness of the columns depend on cooling rate, and what does that tell us about the depth of those intrusions? Believe me, I've been trying to find some basic rules that I can use anytime I take a group out. It's going to happen this afternoon. Frickin' Julie and Jess are going to be asking me question after question about the physics of the columns, and I'm just going to be pretending I don't hear them. It's like, I'm sorry, I don't have my hearing aids in. I can't hear you.
Why are they so?
I can't hear you. I'm sorry. I'm sorry. I can't hear you. La, 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 la. 3 more. Kevin, doesn't much of the Ellensburg Formation predate the uplift of the modern Cascades? Yes. If we believe that email that I shared on Saturday night, Kevin, Paul Hammond says Crystal Mountain, which is the other side of the crest of the Cascades, is a big wad of Ellensburg Formation. Like, okay, that's a whole nother angle. How much stuff west of the crest of the Cascades is called something else, but is really Ellensburg Formation? Wow. Can we well, maybe I should try the color thing. This winter we had a color scheme by decade. Maybe I should do the same color scheme, but it should be like 16 to 14, 14 to 12, 12 to 10. That'd be fun. I'm genuflecting in front of you. The hammer clip is so old that it's not worth bringing up with these guys. Nobody knows about the hammer blooper anymore. I got the hammer in my office, but it used to be very exciting for people. Now they're like, what? It's just a hammer. Thank you. Okay, I will try hard not to have this Plan C approach happen again, but I guess it's nice to know that it's a possibility in case I run into the same problems again, but I got to run. Okay? Thanks, everybody. I love you and goodbye from Ellensburg, Washington. Does this not work on a FaceTime camera? It should. Thank you. I love you and goodbye. Okay, guys. Yeah. Should we, let me help you just a sec. So you